There it goes. Yeah. Okay, so this is a technique called a partial fraction decomposition. I'm going to take a fraction and decompose it into parts. That's where it gets its catchy name. And a couple questions that should instantly come to mind is what is it and why are we doing it? And I'm going to answer them both with the same example. Okay, so what is it? It is a technique that allows you to take a rational expression like that and right there and break it down, decompose, into multiple parts. Why on God's green earth would you want to take that and break it down into parts? And the reason it's a reason that you really can't appreciate yet. In calculus, you have to use a lot of formulas. Things have to fit a formula in order for you to do things with it. This particular thing is called integration, and it's kind of a tough thing in and of itself. But in order to integrate an expression, it has to fit a formula. And in many cases, when you have a rational expression like this, there is no formula. So you break it down into smaller pieces that you can handle more easily. So this is the process of breaking it down into those smaller pieces. And it's not in the book that we have now. It's in the white book that we don't use anymore. But I'm still doing it because when you do get to this point in calculus in college, you're going to get one or two really quick examples of this, and it's going to be part of the bigger problem, and he's going to fly. So it's going to be much harder than, so at least you have seen it now. And here is the general plan. We're going to take that, and we're going to break it into two fractions. The denominator needs to be factored, and this is let's see, this is x minus 3 x plus 2. So those are the factors of the denominator. So we are going to make one partial fraction for each linear factor of the denominator. For each linear factor. Linear, remember, means x to the first power. These two factors are both linear. When you have a linear factor, your temporary numerator is going to be a single letter. So we're going to do two fractions. One, a over x minus 3, and we're going to do b over x plus 2. So factor the denominator. For each factor of the denominator, you're going to make a fraction. Two factors, right? And we have at least two or more fractions, in this case just two. You'll see other examples. For each linear factor, you get a single letter. So here's the idea. If we can find out what we can put in place of a and b so that when you add these two together you get what you started with, then we're done. We're breaking this down into two smaller pieces that are easier to handle. So we need to find out what number could we put in for a, what number could we put in for b, so that when we add all this back up, we get x plus 7. We just finished doing rational equations, and look, lo and behold, we have a rational equation. So if we multiply through by the least common multiple here, we're going to get rid of the fraction. So that's exactly what's going to happen. We're going to multiply both sides by x minus 3, x plus 2. And when that happens, all of this will always cancel out, and you'll be left with the numerator of the left side every time. And you handle these like you have been for the last few days. This would be a, x plus 2. This would be b, x minus 3. Okay. Now, here is the weird step. What I've done here at the very beginning was I set up an equation so that when I do eventually find A and B, they're going to add together to get what I started with. So what's on the left and what's on the right are really the same thing. It's just been broken down. Like in the same way that 10 is equal to 6 plus 4. Okay? They both really mean the same thing. They both mean 10, except one's been broken down into two parts and rewritten as addition. You see that? So this has been broken down and rewritten into addition, and this stands for two numbers that we have not yet found. So from Algebra 1, you'll remember sometimes when you solve equations, you ended up with a true statement, and the solution for that was all real numbers. Well, we have created an equation that's going to be true for any number of x that you want to put in. Because we've designed it so that these are just like 10 is to 6 plus 4. They're the same thing, they just look a little different. So any value of x that we put in is going to result in a true statement. And that's cool because we can pick any value of x and put this in and solve for A or B. So if I were to choose, if I were to let x, that's a t by the way, let x be negative 2 equal negative 2. It's not writing. Now I am sad. It's really not writing. Go ahead and put a negative 2 there. I'll be right back after these messages. If x were to equal negative 2, then this is what would happen. We'd have a negative 2 plus 7. We'd have a times negative 2 plus 2 plus b times negative 2 minus 3. Maybe some of you see where this is going. We picked a convenient number for x because if you put negative 2 in for x, this becomes 0. And you're left with an equation with only one unknown, which you can solve. Negative 2 plus 7 is 5. And over here we have negative 2 minus 3 will be negative 5b. Yeah, because a times 0 would just be 0. And to get b by itself, we divide both sides by negative 5. And I have that b equals negative 1. Isn't that just groovy to the max? This is, yeah. So this number was picked because it made that 0. So I'm going to pick another number that's going to make this 0, and what is that number going to be? 3, right? So let x equal 3, and what I have is 3 plus 7 equals a times 3 plus 2 plus b 3 minus 3. Well, 7 plus 3 is 10. 3 plus 2 is 5, so I've got 5a plus, well, 3 minus 3 is 0, and b times 0 would be 0. So 5a plus 0 are just 5a. Three or negative 2, because what would make that 0? And then divide both sides by 5, and a would be 2. So my final answer is that x plus 7 over x squared minus x minus 6 could be broken down into a is 2 over x minus 3, and b is negative 1. Box that one loud and proud. do that? Should we do that one again, or should we go to level 2? Emily is ready to have one. Emily wants an easy one. Emily wants an easy one. Okay. How about 3 over x squared minus 3x? How's that for a partial fraction trial?
And then so you have a over x plus b over x minus 3. We multiply the whole problem by x and x minus 3, which gives you 3 equals a times x plus b x minus 3. To get a,
The x times 3 gives us the a, and the x gives us b.
oh yeah,
Turn it upside down.
Because you give the a already has the
minus
x gives us the
3
b.
plus b
It just says make it harder. Yeah.
x, and then you have 3 equals, you put a, you put the 3 with the a as x, that cancels, leaving you with 3 equals 3b. Divide by 3 both sides, you have 1 equals b. Over here you'd have 3 equals, you'd have put a, put 0 in for x, and plus b times 0. Then you'd have 3 equals negative 3 a, and that cancels out. Divide by negative 3, you get negative 1 equals a, and so your final would be 3